and we'll start the next video, that is the operational amplifier, right? So let me take some problems. So this is the GATE 2005 problem, 2005, and the circuit of the problem is this is Vs given 1 volt, Vd 5 volt, and Vg over here, Vg is 3 volt. Okay, transfer characteristics is also given, Id, and this is VGS, and this is kind of, here it's 1 volt, and this is the transfer characteristics actually. And the question is, for an n-channel MOSFET, okay, and it's a transfer curve shown in the figure. The threshold voltage is, the Vt is, and the options are given 1 volt and device in active region, 1 volt and device is in active region. Okay, option B is given -1 volt and saturation region. Option C, 1 volt and saturation, and option D is given -1 volt and active region, -1 volt and active region. So friends, we have seen if VDS is greater than VGS minus VT, then it's saturation. We have seen this. Okay, and if VDS is less than VGS minus VT, it will be active region. Is it okay? I'll check the condition over here because I'm given with VD and everything I'm given with. So let's check the condition. Threshold is 1 volt. It's 1 volt is given over here only. After VT we are getting the current into the circuit. So 1 volt is correct. No problem at all. VT is 1 volt. Definitely 1 volt. So we'll be having only two options. Option A and C. But what about this? It's working in saturation or active region? So let's check it. VDS you need. Between D and S, you have 4 volt. Okay. And what about VGS? VGS is 2 volt. 3 minus 1. That is VGS minus 1 volt. So this is 1. And definitely 4 is greater than 1. So the system is working in saturation region and threshold voltage is 1 volt. So correct option is C. This was the 2 marks. So if you are clear with the basics of FET, then sometimes they are asking this type of question also. Hardly it will take 30 seconds. By seeing it once time only, we can judge the the threshold voltage will be 1 volt only. Definitely 2 options eliminated, you are having only with 2. Now you can check these 2 conditions. Is it okay? Let's come to the next. So this is GATE problem 2002, 2 marks problem, and the circuit of the problem is given. I'll take 30 seconds to draw it. 3K. Okay. 2.5K. 2.5K connected in parallel with capacitor CS. So definitely it will be common source. Why common source? I think you know very well now. The value of this is given 1 mega. 1 mega. See, this is the input resistance, the range of mega. C1. Over here V in you applied, and this is VDD, and VDD is given over here 10 volt. ID is also given over here 1 milliampere. Okay, and I'm taking output. This is C2, and here is the output V0. Everything is clear. Now the question is the voltage gain AV, V0 by V in of the JFET amplifier shown in the figure is. The question is find out AV, and the options are given. 18, option B -18, option C 6, option D -6. Okay friends, and apart from this, IDSS is given 10 milliampere, and VP is also given -5 volt. Is it okay? So if you will see this circuit carefully, this is kind of in the FET circuit. We have to analyze AC as well, DC analysis. If you want this AV, means V0 by V in both are AC, we need to do the AC as well as DC, both analysis, right? But this is the common source. You can directly remember one thing in the common source. The gain is nothing but minus GMRD. This is the gain. After doing analysis, DC and AC analysis over the FET, in the common source we have found that the voltage gain is nothing but minus GMRD. Similarly, in common emitter, in the transistor I'm talking about, AV was minus GMRC. Okay, so RC is the output resistance in the collector circuit, here in the drain circuit. Okay, and here it's RD over here. Everything is same. You need to calculate only transconductance because everything is given over here. IDSS, VP. So you can easily calculate a GM. Okay, if you will follow all DC and AC analysis, this will take 5 to 6 minutes. Okay, and in GATE examination, we don't have that much of time. Okay, so friends, GM, we know the ready-made formula. As you know, we have seen GM is 2IDSS by VP 1 minus VGS by VP, if you remember this. Okay, so let's put the values. GM will be 2 into IDSS is given 10 milli. VP is given, take the mode of it, it's 5, and 1 minus VGS. Do you have VGS? Not given, but we can calculate. See, this is G and this is S. VGS is nothing but VG minus VS. Is it okay? If we'll talk about the VGS, VS is the voltage over here and VG is the voltage over here. This VGS comes under DC analysis. In the DC analysis, if you will what you will do, you will turn off the AC circuit, so the gate part will be connected with 0 volt. No voltage or no battery is connected with G, and in the DC analysis this will be when you are having 2.5K, in which you are having the current 1 milliampere. So the voltage drop will be 2.5K into 1, so it will be 2.5K. So your VGS is minus 2.5. Is it okay? You have to keep this value over here. So it will be 2.5 and VP is minus 5, like this. So it will be 2 times 4 milli, 1 minus, this is half. So this is 4 milli into half. So it is 2 millisiemens. This is your GM. Now you calculated GM. Now come to the AV. AV is nothing but, let me erase some part, then we will see that. Wait a minute. The formula for AV is nothing but minus GMRD. Okay, minus GM is what you have calculated 2 milli. RE is what given in the circuit, it's 3K. So finally you have minus 6. AV is minus 6. Do we have in the options? Yes, I have. So the minus 6 is the answer. Is it okay? So friend, this is the question based on the AC and DC analysis, or we have to do the small signal analysis into it. Okay. For this circuit, the small signal analysis is already done because IDSS is given, VP is given, everything is given. And we have the ready-made formula to work with, and the formula for voltage gain is minus GMRD. Now, our work is totally focused on GM only. We have to calculate the GM. Once GM is in your hand, you can put the values in this formula, and because RD is already given, and you can calculate the AV. If you remember this question you can do in 2 minutes, less than 2 minutes. But suppose you don't remember this formula, what will happen? You'll take 5 to 6 minutes to solve this circuit. Is it okay? So let's come to, so friend, this is the GATE 2017 problem and 2 marks problem. And the problem circuit is given 8 volt, 1K drain resistor, over here 1K, and grounded. Okay, this is the source. Over here you have again 3 mega and 5 mega. Okay, connected like this. Okay, fine. The current in this is ID. And the question is, now I'm telling you, this is NMOS. For the circuit shown in the figure, let me change the pen. For the circuit shown in the figure, assume that the NMOS transistor is in saturation. The condition is given saturation. The condition is given saturation condition. Okay. Its threshold voltage VTH is 1 volt. Threshold voltage is given 1 volt. Fine. And its transconductance parameters mu n COX W by L is also given 1 milliampere volt square. Perfectly fine. Neglect channel length modulation and body effect. Under these conditions, the drain current ID in milliampere is, this is the question. Under these conditions, the circuit is working in saturation region. The values are given over here. We have to calculate ID in milliampere. So if you remember, we have seen the formula for ID, right, for the MOSFET, and that was mu n COX W by L. Inside we have seen 1 minus, wait a minute, this is VGS actually, VGS minus VT into VDS minus VDS square by 2. Okay, but for the ohmic reason, the VDS is very small. At very small value of VDS, the ohmic reason occurs. So this term we can neglect. So we are remained with ID equal to mu n COX W by L VGS minus VT into VDS. Is it okay to you? But this is the saturation given, right? So in the saturation, the circuit is mu n COX W by L divided by 2 also VGS minus VT whole square. This is the condition for saturation. So everything is given in this. ID saturation. No, they're asking for ID only. IDSS is given. No IDSS is given. So mu n COX W by L given 1 milli divided by 2. VGS, we don't have VGS minus VT, yes, we have 1 whole square. And here ID. Easy, let me erase some part and then I'll solve it. I have used this all conditions, so I'll removing it, okay. So now your equation is, your equation ID 1m by 2 VGS minus 1 square, equation 1. Now for following this we have to do, see where is the ID? Here is the ID, means ID is over here also. So can you make the relation between ID and VGS to solve this equation, because we have only one equation in which two variables are given. So we need another equation having same variables. So two equation, two variables, we can easily solve it, right? So please come over here. What is the voltage over here? The voltage will be 8 into 5. So it will be 5 volt definitely. Over here the voltage is 5 volt. Means VG is 5 volt. What is VS? This is VS. VS is 1K into ID. 1K into ID. So I need VGS. So VGS will become 5 minus KID. 5 minus 1K ID. Minus 1 square. I'm putting the value in this. This is ID. 2 I'll take over here, 1 milli. So 4 minus 1 KID square. Here 1 milli equal to 2 ID. So in this equation only you are remain with the ID only. When you will calculate this ID, so it will be 2 milliampere. Okay, 2 milliampere. You can keep this milli as it is because you need to take value in milliampere. They're asking in the milliampere only. So this is your circuit. When you will solve this circuit, you will get ID equal to 2 milliampere. Is it okay? This is easy question. You have to remember these equations. Okay. I'm telling you these equations again. The MOSFET current ID is given by mu n COX W by L inside VGS minus VT into VDS minus VDS square by 2. Is it okay to you? Now, this is the normal general formula, but in the active region only, in the active region, VDS is very small actually. So square of VDS will become so small. So you are remained with mu n COX W by L VGS minus VT into VDS only. But if we'll talk about the saturation region, this formula become mu n COX W by 2L VGS minus VT whole square. Because in saturation VDS is VGS minus VT. So instead of VDS we kept over here VGS minus VT. So this becomes square. Here also the half of that available. So when you will subtract, it will become VGS minus VT square by 2. So this 2 I'm taking out. So for the saturation region, the formula is mu n COX W by L VGS minus VT whole square divided by 2. I hope this is clear to you. Let's come to the next problem. So the next problem is given. Let me draw the circuit. VDD connected with 10K and here is the given FET and M1. Okay, this is MOSFET given over here, and here this is V in, V out given over here. Now the question is, for the MOSFET M1, okay, fine, shown in the figure, assume W by L is 2 given, VDD is 2 volt, mu n COX is given, mu n COX is given 100 microampere per volt square, and threshold voltage is also given, that is 0.5. Definitely it's volt. The transistor M1 switches from saturation region to linear region. It switches saturation to linear. Okay. Now the question is, when V in is equal to, when it will be happen that circuit will switch from saturation to linear. So simply they are asking the point between saturation and linear region. Okay. So in the saturation region, the formula for ID is again mu n COX W by L divided by 2. Here VGS minus VT whole square. Is it okay to you? Now everything is given. W by L is given 2. Mu n COX is given 100 micro divided by 2 into 2. Can I write it VDS square? Because in saturation VDS is nothing but VGS minus VT. This is okay. And VDS is VD minus VS. What is VS? VS is directly connected to 0. So this will be equal to VD only. And VD is nothing but V output. Is it okay? So can I write this? 100 micro equal to square. Can I write it? And this is ID. Equation 1. Is it okay to you? Now if in this outer circuit I'll apply KVL, it will be 2, this 2 equal to 2 minus 10k ID and minus V naught equal to 0. So 2 minus V naught equal to 10k of ID. Okay. Keep this ID from equation number 1. Put this ID into this. So 2 minus V naught equal to 10k into ID is 100 micro V naught square. Okay. So it will be only 1. 2 minus V naught. And here it will be V naught square. So V naught square plus V minus 2 equal to 0. This is V naught only. Okay. So by this equation we are getting V naught equal to 1 volt, because at V naught is 1 only satisfies this equation. So the V naught is 1 volt. Now you calculated V naught, but they are asking find out V in. What is the V in? Right. So you have find out the V naught. Okay, fine. So V naught, or this is nothing but VD also, VDS also, because A is 0. So at the transaction point means when these two things occur, the VDS is just equal to VGS minus VT. Is it okay? This is the condition. Let me erase some part so it will be clear to understand. Wait a minute. Saturation to linear or linear to saturation, whatever, it will be only possible when VDS is equal to VGS minus VT. Okay. So, wait. What is VDS? VDS is equal to V naught. You calculated 1 volt. What is VGS? VGS V in. S is 0. So it will be V in minus 0.5 is given. So V in is 1.5 volt. So when V in is 1.5 volt, then only this is possible. Okay. So this is about this question. Let's come to the next. So this is GATE 2014 problem. Wait a minute. The problem is given the diagram. This is VDD connected with R. Grounded and drain, and this is gate. This is the circuit given. They have given 4 options: 0.625, option B 0.75, option C 1.125, and the last option 1.5. Now the question is, for the N channel MOS transistor shown in the figure, this is N channel, okay, like this. The threshold voltage VTH is given 0.8. Okay. Neglect channel length modulation effects. When the drain voltage VD is 1.6, this voltage VD is 1.6 volt. They are saying when this is 1.6 volt, the drain current was found to be 0.5. The ID was found to be 0.5 milliampere. Okay. If VD is adjusted to 2 volt, the question is, if VD is 2, by changing the value of R, here we change the value of R and making VD equal to 2, the new value of ID in milliampere, and the options are given over here. Okay, is it okay? VTH is given for this NMOS. VD, when VD is 1.6 volt, the current in the circuit is 0.5 milli. The question is, if VD is 2, what will be the ID? Is it okay? So for this particular question, first, what is our equation? Our equation ID. So first we have to find in which region this circuit is working. If VDS is greater than VGS minus VT, then it's a saturation. Let's check it. What is VGS? GH, this is completely 0, minus threshold is 0.8. I'm sorry. 0.8 is threshold. Okay, 0.8. Fine. So this will be negative point end. Obviously this will be greater than this because VD is given 1.6. So 1.6 is greater than 0.8. So definitely your circuit or your MOSFET is working in saturation region. So we have to consider the saturation region current ID. Okay. And your current will be here mu n COX W by L by 2 VGS minus VT whole square. Is it okay? And this is the, let's take this entire thing is constant K dash. So ID is nothing but K dash VGS minus VT whole square. And one more thing, if you will observe this question carefully, you will find out VD is equal to VG, both are same. Means VD equal to VG, both are same. And what about VGS? VGS is VG minus VS. VS is 0, so it's a VG. VG is VD only. So your current ID is given 0.5 milliampere. You don't know this. VGS is nothing but VD 1.6 minus 0.8 square. So 0.5 equal to K 0.8 square. K is nothing but 0.5 divided by 0.8 square. So if you will calculate the value of, it will be 0.78 milliampere per volt. Okay. This is the K dash value. Now the question is, now if your VD is 2, find out the ID. So ID we have to find. Now we know this value 0.78. This is 0.78. Okay. And milli I'll take at the output. as a milliampere current. So inside VD is 2 minus 0.8 whole square. Is it okay to you? So your ID will be for this 1.123 milliampere. So option C is correct. Is it okay? This is about this question. Let's come to the next one. The problem is GATE 2014 problem, 2 marks. And the problem figure is, let me draw the figure first. This is minus 5 volt, okay? This is incoming and this is outgoing, like this situation is. Here is the current ID 10K, 10K connected ground, and here it is plus 12 volt. Everything is given minus 5 volt. Okay. Now, for the MOSFET shown in the figure, the threshold voltage VT is given. Mode of VT is given 2 volt, and K is given, and K is nothing but 1 by 2 mu C W by L is equal to 0.1 milliampere per volt square. The value of ID, they are asking the value of ID in milliampere is, okay. So friends, so this is the case of again saturation region. The value of saturation parameter is also given over here. So current is nothing but this 0.1 milli VGS minus VT whole square. Is it okay? So you need VGS. This is G. Okay, VG is 0. You need VGS, right? So you need VG minus VS. VG is 0. And this is VS, that is minus 5. So become plus 5. VGS is 5 volt. So this is 0.15. VT is given 2 whole square milliampere. Current ID is, so 0.1 into this is 9 milliampere. So it will be 0.9 milliampere is your answer ID. So you have to write over there 0.9 only, not 0.0009, because they are asking in milliampere only. So this is again one easy problem. Let's come to the next one. So let's come to the next problem, and the problem given is, let me draw the circuit. The circuit is RD connected with 5 volt. This is grounded. Here it's VD 0.1 volt. The current over here is ID. Here it's 5 volt. It's 5 volt. Correct? Now the question is, design the circuit. Wait a minute. The question says, design the circuit. Wait a minute. For this given circuit, establish a drain voltage 0.1 volt. What is the effective resistance between drain and source? Between drain and source, what is the effective resistance? Let's take it RDS. They are asking. Perfectly fine. And the conditions are given. Threshold voltage 1 volt and mu and omega L COX is given 1 milliampere per volt square. Okay, so this is the condition. So they're asking find out this RDS. Is it okay? And RD is also unknown, and they're asking for the RDS, the resistance between these two. Correct, friends? So first check it. The system is working in which region? Okay. the condition is you have to check VDS, VGS minus VT. Here the S is definitely 0, so it is condition is VD, VG minus VT. VG is 5 volt given and threshold voltage 1 volt is given. VD is 0.1 only, so definitely this one is greater. 4 is greater than 0.1. It means your system is working or your circuit is working in active region or ohmic region or triode region. Is it okay? So we'll apply the formula for current for triode region. If you remember the formula was ID is nothing but mu n CoX W by L VGS minus VT into VDS minus VDS whole square. Let me take the pen and then I'll write over here. ID is for the ohmic region I'm going to write, and that is mu n CoX W by L. Is it okay? Inside VGS minus VT VDS minus VDS whole square. Is it okay? Now in this formula this term is given. So ID is, what is this term? 1 milli. So 1 milli. What is VGS? VGS is nothing but VG minus VT. VG is 5 and this is 1. So this will become 4. What about VD? VD is 0.1 minus 0.1 whole square. Is it okay? Well, who is unknown? Over here only ID is unknown. So ID is 1 milli. This is 0.4 minus 0.01. So ultimately you will get, in this original formula I forgot divide by 2 also. This is also given over there like this. So it's become 0.05 and ID will become 0.395 milliampere. Your current, you get the current. For the given condition you get the current ID. Now can you calculate this RDS? Yes, you can calculate. So this RD will be 5 minus 0.1 divided by ID. ID is 0.395 milli. So this will be 4.9 divided by 0.395 milli. Is it okay? So it will be 12.4 kilo ohm. So if the circuit is like this, you want VD equal to 0.1. So you need to keep RD equal to 12.4K. Now they're asking what is RDS. So let me remove some part, erase some part, then I'll show you what is RDS and how to calculate it. Okay. Again, you can remember this formula. ID is equal to mu n CoX W by L inside VGS minus VT into VDS minus VDS whole square by 2. Correct? And for the saturation region, mu n CoX W by L by 2 also, and inside VGS minus VT whole square. Now RDS. Let me take pen. The voltage difference is VDS and current into the circuit ID is nothing but RDS. Is it okay? The voltage difference is 0.1 minus 0 divided by current is 0.395 milliampere. So RDS, if you will calculate the 253 ohm. This is your answer. Is it okay, friends? Let's take another problem. The circuit is given. Let me draw the circuit. Circuit is over here. It's R. VDD is given 3 volt. This is definitely drain part. The source is grounded. NMOS. The VG is nothing but VD now. Here I'm taking V0. In the circuit, ID is the current. everything is like this. So these things are given over here. Now design the circuit given to obtain a current ID equal to 80 microampere. Okay, if ID is 80 microampere, find the value of R. Find the value of R, and given datas are Vt is given 0.6, mu n Cox is given 200 microampere per volt square, L is given 0.8 micrometer, and W is given 4 micrometer. Is it okay? These are the data given over here. Now I have to find out this R. ID is given, everything is given. Now you need to take formula. Which formula you will take over here? So before that you have to check in which region that transistor is working. VGS minus VT. So AS is definitely 0. So your new formula will be VD VG minus VT. VT is given 0.6. VG and VD both are same. So this is VD and this is also VD. Okay. So VD will be definitely greater than VD minus 0.6. Is it okay? So the system is working in the saturation region. So if it is working in the saturation region, let me take the saturation current ID. And if you remember the formula, the current ID was mu n Cox W by L divided by 2 also VGS minus VT whole square. Is it okay? This is the formula for you. Now everything is given. What is ID? 80 micro. Perfect. Mu n Cox is given 200 micro. Divide by 2. W is given 4 micro and this is given 0.8 micro. Micro will cancel out. VGS minus VT whole square. This micro will cancel out to this. And finally you have, this is 2. This 0.8 will come to this side. So this will be 64. And divide by 400 equal to VGS minus 0.6 square. You need to take under root both sides. So here it will be 8 by 20 equal to VGS minus 0.6. Is it okay? So VGS is equal to 8 by 20 plus 0.6. So this will be 0.4 plus 0.6, 1 volt. Now VGS is 1 volt. Now you have to calculate this R. They're asking for R. VGS means VG. VG means 1 volt. For this circuit, VG is nothing but V0 also over here. So here you get the value 1 volt. Now they're asking R. Okay. So now this is very easy to calculate R. Let me erase some part, then I'll show you. So this type of questions are coming in the exam actually. And they're asking 2 marks question for AC fellow for instrumentation. This is not important topic, but in last 2017 they asked one question. The same question we have done in the class also. Now you need to calculate R. So R is 3 minus 1 divided by ID, and ID is 80 micro. So this will be 3 minus 1, 2 by 80 into 10 to the power 6. So it will be 1 by 40 into 10 to the power 6. So this is R. So R is, let's take it 1000 K divided by 40. So this will be 25. So R is 25 K, your answer. Is it clear to you? Let's come to the next problem. Let's come to the next problem, and this is the last problem of this session. Here RD is given, again RD is unknown. VDSS is given 2.5 volt, no problem at all. Now RS is also unknown over here, and VSS also given, and that is minus 2.5 volt, like this, and this is V0. Okay, and the gate is grounded G S D. This is the circuit given. Now the question is, design the circuit shown below so that transistor operate at ID equal to 0.4. ID equal to 0.4 milliampere. Right? VD is given 0.5 volt. And transistor has VT is given. VT threshold voltage is given 0.7 volt. Mu n COX is given. Mu n COX 100 micro ampere volt square. L is given 1 micrometer and W is given 32 micrometer. Okay, now they're asking find out RD and RS. Okay, so friends, you need to check whether the system is working in active region or saturation region. What is the condition? You have to check VDS minus, this is not minus, VGS minus VT. VT is fixed given over here 0.7. Now you need to calculate VGS. Okay, VG is given 0. So this will be VDS. This will be minus VS. Okay, the condition is like this. So I can write this VD minus VS. Minus VS this side 0.7. This VS can cancel out. VD is given and the VD is what is given in the question? 0.5 over here, 0.5 given. So 0.5. Here this side, so definitely the situation is like this. So this part is greater than this, means definitely it's working in saturation region. Okay. So once you identify the system is working in saturation region, now you know the formula for current, and formula is ID equal to mu n COX W by L divided by 2 also VGS minus VT whole square. Okay, now mu n COX is 100 micro divided by 2. W is given 32 micro and this is 1 micro. Micro will cancel out. Okay, ID is given 0.4 milli. VGS minus VT. So we need to calculate VGS. What about VT? VT is given 0.7 and whole square. Okay, so this will be 16 and this will be 0.4 milli. This will be 0.1 milli into 16. So milli will cancel out. VGS minus 0.7 square. So this will be like this. So 4 by 16 this side. VGS minus 0.7 square. So this will be 1 by 2. Let's take root both sides. So VGS minus 0.7 is equal to 0.5. So VGS is 1.2. Now VGS is 1.2 in your hand. Means between this and this you have 1.2. Now if you remember, VG is 0. So minus VS is 1.2. So VS is minus 1.2. So voltage at this point is minus 1.2 volt. Is it okay? Now you need to calculate RS. Let me erase some part. Wait. So for the saturation, what is the formula for current? It's mu n CoX W by 2L into VGS minus VT whole square. Okay. For saturation region. How to check it's working in saturation or linear region? The condition is VDS should be greater or equal VGS minus VT. Okay friends. So your VS is came minus 1.2. Now they're asking RS and RD. Do you have current? Yes, you have the current. You have the current. Now the current is, see, over here the current is like this. So ID is definitely minus 1.2 plus 2.5 divided by RS. ID is already we have 0.4 milli. So this will become 1.3 divided by RS. So RS is 1.3 divided by 0.4 K. Is it okay? So RS is 13 by 4 K ohm. And what about RD? You can calculate RD also. Wait. So RD is nothing but 2.5 minus 0.5 divided by ID. Is it okay? 2.5 minus 0.5, it will be 2, and ID is given. What's your ID? 0.4 milli. 0.4 milli. Milli will become K. It will be 20. So this is 5K. RD is 5K. RS is 13 by 4K. So friend, this is all about the BJT and FET. So from the next video onwards, we'll start the operational amplifier. We have done many problems over here. I think all your doubts are clear now. So I would like to tell one more thing to you people. Please do problems. You can prefer last year get papers. So it will enhance your knowledge and you will be conceptually strong. Okay friends, we'll meet in the next. Till then, take care and bye.